May 6, 1941, the Beast takes flight. Farmingdale, Long Island, New York. Test pilot Lowry Brabham advanced the throttle on the XP-47B prototype, feeling 2,000 horsepower surge through the massive Pratt & Whitney R2800 double Wasp engine. The aircraft, wider, heavier, and more powerful than any single-engine fighter America had ever built, accelerated down the runway and lifted into the sky. Brabham spent 30 minutes airborne, evaluating handling characteristics of what seemed less like a fighter and more like a tank with wings. The XP-47B weighed 12,700 pounds fully loaded, nearly double the weight of contemporary fighters. Its massive 18-cylinder radial engine dominated the nose, giving the aircraft a blunt, aggressive appearance that would earn it the nickname Jug, short for Juggernaut. German intelligence officers monitoring American fighter development through various sources dismissed early reports about the P-47. A fighter weighing 6 tons, powered by a 2,000 horsepower engine? The specifications seemed exaggerated. German experience taught that fighters required speed and maneuverability, achieved through lightweight designs with modest power. Building a single-engine fighter around such a massive engine violated every principle of fighter design. The Germans' dismissal was understandable, but catastrophically wrong. The P-47 Thunderbolt would become one of World War II's most effective fighters, equally capable as high-altitude bomber escort, low-level ground attack aircraft, and air superiority fighter. More importantly for this story, it would demonstrate American industry's ability to mass-produce complex aircraft using automotive-inspired manufacturing techniques that transformed Republic Aviation from a small manufacturer into one of America's largest aircraft producers. Between 1942 and 1945, Republic's Farmingdale facility built 9,086 Thunderbolts, roughly 60% of total P-47 production from that single plant. Add Evansville, Indiana production, and the total reaches 15,683 P-47s. At peak efficiency, Farmingdale delivered one completed fighter every 2 hours, 24 hours daily. The story of how this happened involves an engine so complex it contained 2,804 moving parts, a designer who understood that bigger could be better, and a factory that applied Henry Ford's assembly line principles to building what pilots called the most rugged, reliable fighter they ever flew.
The P-47's genesis began not with military requirements, but with a designer's vision of what a fighter should be. Alexander Kartveli, born in Tiflis, Georgia, then part of the Russian Empire, fled the Bolshevik Revolution, studied aeronautical engineering in Paris, and immigrated to America in 1927. By 1931, he was chief engineer at Seversky Aircraft Corporation, later renamed Republic Aviation, designing fighters for the U.S. Army Air Corps. Kartveli's design philosophy differed fundamentally from European and Japanese approaches emphasizing lightweight agility. He believed American industrial capacity and pilot training could leverage heavy, powerful fighters that accepted weight penalties for superior firepower, armor protection, and high-altitude performance. In June 1940, as the Battle of Britain raged, Kartveli proposed the AP-10, a radical redesign of Republic's P-43 fighter. Instead of inline engines favored by European designers, Kartveli built around the largest, most powerful radial engine available, Pratt & Whitney's experimental R2800 double Wasp, producing 2,000 horsepower from 18 cylinders arranged in 2 rows. The engine's massive diameter, 52.8 inches, dictated the aircraft's broad, horse-collar cowling that would become the P-47's most recognizable feature. Kartveli positioned an exhaust-driven turbo supercharger in the rear fuselage, connected to the engine by ducts running along each side of the cockpit. This arrangement, complex and unconventional, would prove crucial to the P-47's high-altitude performance. Armament was equally ambitious. 8 M2 Browning .50 caliber machine guns, 4 mounted in each wing, more firepower than most contemporary fighters. With 425 rounds per gun, the P-47 could deliver devastating bursts that shredded enemy aircraft and ground targets alike. The Army Air Corps ordered a prototype on September 6, 1940, 14 months before Pearl Harbor. Despite the P-47B not yet flying, a production order for 773 aircraft followed on September 13, 1940. The unprecedented decision reflected urgent recognition that war was coming and advanced fighters would be essential. When the P-47B flew on May 6, 1941, it validated Kartveli's vision while revealing challenges that would plague early production. The aircraft was heavy, complex, and expensive, but it worked, and with war approaching, works was sufficient. Refinement could come later.
The P-47's heart was Pratt & Whitney's R-2800 double Wasp, arguably the finest piston aircraft engine ever built. Specifications: configuration 18-cylinder, 2-row radial. Displacement 2,804 cubic inches, 46 liters. Bore and stroke 5.75 inches by 6.00 inches. Compression ratio 6.75 to 1. Power output 2,000 horsepower at 2,700 RPM standard. War emergency power up to 2,800 horsepower with water injection, later variants. Weight 2,360 pounds. Moving parts 2,804 individual components. The R-2800 powered not just the P-47, but also the Navy's F-6F Hellcat, F-4U Corsair, the P-61 Black Widow Night Fighter, B-26 Marauder Bomber, and C-46 Commando Transport. Its reliability and power output made it the most successful large aircraft engine of World War II. Engineering marvel. The 2-row radial configuration placed 9 cylinders in the front row and 9 in the rear row, all firing in precisely timed sequence to maintain smooth power delivery. Each cylinder was individually forged aluminum with steel cylinder barrels, cooled by airflow channeled through cowl flaps. Sodium-cooled exhaust valves handled temperatures exceeding 1,400 degrees Fahrenheit. The supercharger, critical for maintaining power at altitude, compressed intake air using exhaust-driven turbines. The P-47's turbo supercharger sat in the rear fuselage, connected to the engine by ducts that gave the fighter its distinctive bulky appearance. This system allowed the R-2800 to maintain sea-level power up to 30,000 feet, crucial for bomber escort missions where German fighters attacked from high altitude. Complexity. Building an R-2800 required extraordinary precision, tolerances measured in thousandths of an inch, bearings that had to withstand enormous loads while spinning at 2,700 RPM, valves opening and closing 1,350 times per minute, pistons traveling 22 feet per second at maximum RPM. Pratt & Whitney couldn't produce R-2800s fast enough to meet demand. The company subcontracted production to Ford, Nash Kellinator, Chevrolet, Buick, Continental, and Jacobs Engine Company. Training workers to build engines this complex to required tolerances was as challenging as the engineering itself. By war's end, Pratt & Whitney and their subcontractors had built over 125,000 R-2800 engines, a testament to both American industrial capacity and the engine's importance to multiple aircraft programs.
Republic Aviation's Farmingdale factory, located on Long Island's South Shore, began as a modest facility producing Seversky P-35 fighters in small numbers. The P-47 program required complete transformation. Facility expansion. Between 1940 and 1943, Republic constructed additional buildings, expanded floor space from 150,000 square feet to over 1 million square feet, and installed 3 parallel assembly lines that would become the heart of Thunderbolt production. The expansion consumed capital Republic didn't have. Government loans, Reconstruction Finance Corporation financing, and accelerated payment schedules for delivered aircraft provided funding. By 1943, Republic employed over 23,000 workers at Farmingdale, more than triple pre-war employment. First production. The first production P-47B, serial number 415895, was delivered to the Army Air Forces on March 18, 1942. It had taken 10 months from prototype first flight to first production delivery, extraordinarily fast by pre-war standards, but agonizingly slow given urgent wartime needs. Early P-47Bs were plagued with problems. Engine overheating from inadequate cowl flap design, exhaust system failures from thermal stress, hydraulic system leaks affecting landing gear and flaps, electrical system bugs in the complex turbo supercharger controls. Workers at Farmingdale were learning to build fighters far more complex than anything Republic had previously produced. The P-43, Republic's previous production fighter, had been comparatively simple. The P-47 incorporated systems and technologies that workers and engineers were encountering for the first time. Process refinement. Republic applied automotive assembly line principles systematically. Sub-assembly shops. Rather than building complete aircraft on final assembly jigs, Republic broke construction into major modules built in parallel. Forward fuselage with engine mount and cockpit, center fuselage with fuel tanks and equipment, rear fuselage with turbo supercharger installation, wings with landing gear and armament, tail services. These modules converged at final assembly where they were joined, systems tested, and aircraft completed. Moving assembly lines. 3 parallel lines moved aircraft through sequential stations. Each station performed specific tasks: engine installation, hydraulic system hookup, electrical wiring, control surface installation. Workers became specialists at their station's tasks rather than generalists. Component standardization. Republic worked with suppliers to standardize components: tires from B.F. Goodrich, propellers from Curtiss-Wright, instruments from dozens of specialized manufacturers. The coordination required thousands of engineering drawings, specifications, and quality control procedures. Continuous improvement. Engineers tracked man-hours per aircraft, identifying bottlenecks. Training improved skills. Tooling improvements reduced installation time. By late 1943, Republic had reduced assembly time from 3,000 man-hours per aircraft to under 1,500, a 50% reduction through systematic process refinement.
September 20th, 1944. Republic's Farmingdale facility celebrated a milestone. The 10,000th Thunderbolt rolled off the assembly line just 2.5 years after the first P-47B delivery. Production statistics. 1942, 354 P-47s delivered from Farmingdale. 1943, 2,662 P-47s delivered. 1944, 4,284 P-47s delivered. 1945, 1,786 P-47s delivered. Production ended July 1945. Total Farmingdale, 9,086 P-47s. At peak efficiency, in mid-1944, Farmingdale delivered 12 to 15 Thunderbolts daily, one fighter every 1.6 to 2 hours, sustained over months. Workers operated 3 shifts around the clock. As soon as one aircraft completed final inspection and flew off to acceptance, another began the assembly process. Evansville expansion. In 1942, the Army Air Forces contracted with Republic to open a second P-47 production facility in Evansville, Indiana. The inland location reduced vulnerability to coastal submarine attacks and positioned production closer to Midwest suppliers. Evansville's first P-47 was delivered in September 1942.
By 1944, the facility employed 15,000 workers, producing P-47s at rates comparable to Farmingdale. Between 1942 and 1945, Evansville built 6,597 P-47s, bringing total Republic production to 15,683 aircraft. Curtiss-Wright Buffalo. Curtiss-Wright received contracts to build P-47s under license at their Buffalo, New York plant. The Curtiss-built variant was designated P-47G. However, Curtiss struggled with P-47 production. Their plant lacked Republic's refined processes and worker expertise. Only 354 P-47Gs were completed before the contract was canceled in March 1944. Total P-47 production across all manufacturers, 15,683 aircraft, making the Thunderbolt one of the most produced American fighters, exceeded only by the P-51 Mustang.
The P-47D entered production in early 1943 and became the definitive Thunderbolt variant. 12,602 D models constituted 80% of total P-47 production. Key improvements: increased power. Later D models used the R2859 engine with water injection, boosting war emergency power to 2,300 horsepower. This provided crucial performance advantages in combat. Bubble canopy. Beginning with P-47 D-25, Farmingdale, and P-47 D-26, Evansville, the distinctive razorback fuselage spine was eliminated in favor of a bubble canopy providing 360-degree visibility. Pilots overwhelmingly preferred the bubble canopy. The ability to see threats approaching from behind proved crucial in combat. Universal wing. P-47 D-20 and later variants featured underwing hardpoints capable of carrying bombs, rockets, or additional fuel tanks. This transformed the P-47 from pure fighter to versatile fighter-bomber. Paddle blade propeller. Later D models used 13-foot Hamilton Standard or Curtiss electric propellers with wider blades to absorb increased engine power. The larger propellers left only 6 inches ground clearance during takeoff and landing. Pilots quickly learned to hold the tail down until the last possible moment to avoid striking propeller tips on the runway.
P-47 Thunderbolts arrived in England with the 8th Air Force in November 1942. The first combat mission flew on April 8, 1943, a sweep over France that encountered no enemy aircraft. Initial skepticism. Pilots initially disliked the P-47. Compared to nimble British Spitfires, the Thunderbolt felt heavy, sluggish in turns, and slow to respond to control inputs. The aircraft's massive size, largest single-engine fighter in service, seemed antithetical to fighter design principles emphasizing agility. Early missions at medium altitudes where German fighters excelled confirmed these impressions. FW-190s and BF-109s could outturn P-47s in dogfights. The Thunderbolt seemed ill-suited for air combat. Revelation. Then pilots discovered the P-47's strengths. At high altitude, above 25,000 feet, the turbo-supercharged R2800 maintained full power, while German engines gasped for oxygen. In dives, the P-47's weight became an advantage, allowing speeds exceeding 500 miles per hour, where lighter fighters experienced control problems. Most importantly, the Thunderbolt was nearly indestructible. The R2800's 18 cylinders provided redundancy. Aircraft returned from combat with multiple cylinders shot out and engines still running. Armor protecting the pilot and vital systems meant P-47s absorbed damage that would destroy other fighters. The aircraft earned the reputation, "The Jug will bring you home." Ground attack. By mid-1944, P-47s increasingly performed ground attack missions, strafing German airfields, rail yards, tank columns, and supply convoys. The 8.5 caliber machine guns delivered devastating firepower. Underwing rockets and bombs added versatility. German forces learned to fear the distinctive sound of R-2800 engines overhead. P-47s operating in the close air support role destroyed thousands of German tanks, trucks, locomotives, and artillery pieces, directly contributing to Allied ground operations' success.
The 23,000 workers at Farmingdale worked under intense pressure producing aircraft for combat. The work was dangerous, exhausting, and psychologically demanding. Industrial accidents. Heavy machinery, electrical welding equipment, and massive aircraft components created hazardous work environments. Workers were crushed by overhead cranes, burned by welding accidents, or injured by industrial equipment. Safety protocols improved continuously but couldn't eliminate risks entirely. Worker demographics. By 1943, women comprised approximately 40% of Farmingdale's workforce. They operated rivet guns, assembled hydraulic systems, installed electrical wiring, and performed nearly every job except the heaviest physical labor. African Americans and other minorities worked alongside white workers in relatively integrated conditions, unusual for 1940s America, and a testament to wartime necessity overcoming social barriers. Motivation. Workers understood aircraft they built would carry American pilots into combat. Every rivet, every weld, every system installation could mean the difference between a pilot surviving or dying. That knowledge maintained focus despite exhaustion and repetitive work. One Farmingdale worker interviewed years later recalled, "You'd see these brand new P-47s lined up outside the factory, waiting for test pilots. Then they'd fly away and you'd know. Maybe that's the one that'll bring someone home safely. Maybe that's the aircraft that'll save a pilot's life when he gets hit. So you did your job right. Every time." The P-47 program demonstrated that fighters, despite their complexity, could be mass-produced using industrial manufacturing techniques pioneered in automotive factories. Production per year: 1942, 365 total, all manufacturers. 1943, 4,198 total. 1944, 7,797 total, peak year. 1945, 3,323 total. Total, 15,683 P-47s. At peak monthly production in mid-1944, American factories delivered approximately 650 P-47s, more fighters than Germany's entire monthly aircraft production of all types. Combat record. P-47s flew 546,000 combat sorties, dropping 132,000 tons of bombs and firing 135 million rounds of ammunition. They claimed 3,752 enemy aircraft destroyed in air combat, while losing 3,499 Thunderbolts to all causes, a roughly 1-to-1 exchange ratio that belied the aircraft's effectiveness given its primary mission was bomber escort and ground attack rather than air superiority. P-47 pilots included multiple aces. Robert S. Johnson scored 28 victories flying P-47s with the 56th Fighter Group. Francis S. Gabreski scored 28 victories. Both men survived the war and later flew jets in Korea. Post-war. After 1945, surplus P-47s served with dozens of foreign air forces. South American nations operated Thunderbolts into the 1960s, some remaining in service until jets finally replaced them. The aircraft's rugged construction and reliable R-2800 engines enabled decades of use despite increasing obsolescence. A handful of P-47s survive in museums and private collections, maintained in flying condition by enthusiasts who appreciate the Thunderbolt's place in aviation history. The P-47 Thunderbolt represented American industrial philosophy applied to fighter design. Build around the most powerful engine available, accept weight penalties for superior performance at operational altitudes, prioritize pilot protection and aircraft survivability, and arm so heavily that firepower compensates for any lack of agility. The approach violated conventional wisdom. German and Japanese fighters emphasized lightweight and agility. British designs balanced multiple factors. Only America built single-engine fighters weighing 6 tons and powered by 2,000 horsepower engines. The approach worked. the P-47 proved effective as bomber escort, air superiority fighter, and ground attack aircraft. More importantly for this story, the Thunderbolt demonstrated that complex aircraft incorporating advanced engines and systems could be mass-produced using assembly line techniques that transformed aerospace manufacturing. Republic Aviation's Farmingdale facility, producing one fighter every 2 hours at peak efficiency, validated principles that would shape post-war aerospace industry. Modern fighter production still relies on assembly line organization, sub-assembly shops, and continuous process improvement pioneered at Farmingdale. 15,683 P-47 Thunderbolts, each powered by an R-2800 engine containing 2,804 moving parts, each weighing 17,500 pounds fully loaded, double a Spitfire's weight, each carrying 8.5 caliber machine guns and enough ammunition to fire for 20 seconds of sustained combat. Built by workers who had never constructed anything this complex, designed by a Georgian immigrant who understood that bigger could be better, powered by engines so reliable that pilots called them unbreakable. The Germans who dismissed reports of 2,000 horsepower fighters learned the truth when P-47s began escorting bombers deep into Germany, shredding Luftwaffe interceptors with devastating firepower, and returning home despite battle damage that would have destroyed lesser aircraft. The Jug proved that sometimes the biggest, heaviest, most powerful approach was the right approach. And American industry proved it could build 15,683 of them in 3.5 years. One fighter every 2 hours, for years. From Farmingdale, Long Island. That was how Republic Aviation won its war.
In memory of the 23,000 workers at Farmingdale who built Thunderbolts, the pilots who flew them into combat, and all who understood that industrial capacity, properly organized, could produce weapons in quantities enemies couldn't match.